What's going on, everybody? Welcome back to my YouTube channel. Look at this nice and beautiful question on the board that we're going to be solving. And the question says, find all the solutions for k for which k to the 6 is equal to 64. Well, our first step will be for us to move 64 to the left hand side so that we have k to the 6. As 64 crosses to the left, it becomes minus 64 equal to 0. Our next step will be for us to simplify 64. So we have k to the 6 minus 64 is same as 2 to the 6. And this is equal to 0. Our next step will be for us to write these expressions in the form of difference of two squares. That means k to the 6 can be written as k cubed raised to the power of 2 minus 2 to the 6 can be written as 2 cubed raised to the power of 2. And this is equal to 0. So we have this expression in difference of two squares. And this is actually correct because from indices, powers multiply. So 3 times 2 gives 6. The same thing here. 3 times 2 gives 6. So for difference of two squares, an expression as a squared minus b squared, which is a property of difference of two squared, can be written as a minus b times a plus b. Now, comparing this expression to what we have here, you notice that a is in the form of k cubed, so k cubed, and b is in the form of 2 cubes, so 2 cubes. So now let's express this like this. So this is a minus b, that's k cubed minus 2 cubes, times a plus b, that's k cubed plus 2 cubes. And this is equal to 0. So we have two cases. We have k cubed minus 2 cubes to be equal to 0. Or for the other case, we have k cubed plus 2 cubes to be equal to 0. Now let's solve these two cases one after the other. So I'm going to be starting with this first case. So let me call this case 1. I have k cubed minus 2 cubes equal to 0. Well, notice that this is difference of two cubes. For difference of two cubes, we have the property, for example, when I have a cubed minus b cubed, this is equal to a minus b times a squared plus ab plus b squared. So this is a property of difference of two cubes. From this property, we see that a is in the form of k and b is in the form of 2. So let's express this like this. So we have a minus b, that's k minus 2, times a squared, that's k squared, plus ab, plus ab, that's 2 times k, that's 2k, plus b squared, that's 2 squared, which gives 4. And this is equal to 0. Now notice that we have two cases. We have k minus 2 to be equal to 0, or we have this other case, which is k squared plus 2k plus 4 to be equal to 0. Now let's solve these two cases on the next slide. Now for the first case, to get the value for k, we're going to be moving negative 2 to the right hand side so that we have k to be equal to, as negative 2 crosses to the right, it becomes 2. So this is one value for k. Now for this other case, we have a quadratic expression. And we're going to be using the quadratic formula to solve this. So the coefficient of k squared, we take it as our a, and it is 1. The coefficient of k is 2, and that is our b. And the constant term, which will represent our c, is 4. So looking for the value of k and using the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now let's substitute. So we have k to be equal to negative b is 2, plus or minus the square root of b squared, that's 2 squared, which gives 4, minus 4ac, that's 4 times a is 1, times c is 4, all over 2a, which is 2 times 1. So k is equal to negative 2 plus or minus the square root of 4 minus 4 times 1 times 4 is 16, all over 2 times 1, that's 2. So this simplifies into k equal to negative 2 plus or minus the square root of, now 4 minus 16 is negative 12, all over 2. So this becomes k equal to negative 2 plus or minus, well, negative 12 can be simplified into the square root of. Now I'm going to be using a perfect square and another factor of negative 12. 4 is a perfect square, so I'm going to be using 4 times the other factor is 3. So this makes 12, but I have negative, which means I'm going to be multiplying by negative 1 all over 2. So k is equal to negative 2 plus or minus. Well, this expression is same as the square root of 4 times the square root of 3 times the square root of negative 1 all over 2. Now, this gives k to be equal to negative 2 plus or minus the square root of 4 is 2 times root 3, that's root 3, that's 2 root 3, times the square root of negative 1 is iota, so that's times I, all over 2. Now factor out the 2, we have k to be equal to 2 outside, so we have negative 2 divided by 2, that's negative 1, plus or minus 2 root 3i divided by 2 is root 3i, all over 2. So we see that the 2 here can go with the 2 here, leaving a final answer of k to be equal to negative 1 plus or minus the square root of 3i. Now let's move on to our second case. Remember that we are done with this case, which is our case 1. We're now going to be doing our case 2. Let's do that on the next slide. So our case 2 is k cubed plus 2 cubes equal to 0. Now notice that this is an expression of sum of 2 cubes. The property of sum of 2 cubes is, for example, when I have a cube plus b cube, this is equal to a plus b times a squared minus ab plus b squared. Now, by comparison, you notice that a is in the form of k and b is in the form of 2. So let's express this like this. So this is a plus b. So a, that's k plus b, which is 2, times a squared, that's k squared, minus ab, that's k times 2, which gives 2k, and then plus b squared, that's 2 squared, which is 4. And this is equal to 0. So we have two cases. We have k plus 2 to be equal to 0, or we have k squared minus 2k plus 4 to be equal to 0. So for the first case, k is equal to, when I move 2 to the right hand side, it becomes negative 2. Now for the second case, we have a quadratic expression that we're going to be using the quadratic formula to solve. So from this case, we see that a, which is a coefficient of k squared, is 1. And we see that b, which is a coefficient of k, is negative 2. And c, which is a constant term, is 4. So using the quadratic formula, which is k equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So substituting, we have k to be equal to negative b. So negative b is negative 2, plus or minus the square root of b squared, that's negative 2 squared. So negative 2 squared is 4. So let me just put 4 here, minus 4ac, that's 4 times a is 1 and c is 4. That's it. All over 2a, that's 2 times 1. So k now becomes negative times negative gives positive. So I'm going to be having positive 2 plus or minus the square root of, now 4 minus 4 times 1 times 4 is 16. All over 2 times 1, that's 2. So k becomes 2 plus or minus the square root of, now 4 minus 16 is negative 12 all over 2. So k becomes 2 plus or minus, from what we see on our previous slide, we saw that the square root of negative 12 is same as 2 root 3 times I all over 2. Now factorizing the numerator, you notice that 2 is common. So let's factor out 2. So k will be equal to 2 out. Now 2 divided by 2, that's 1, plus or minus 2 root 3i divided by 2, that's root 3i all over 2. And notice that this 2 here can cancel off this 2, leaving behind k to be equal to 1 plus or minus the square root of 3i. So we have 6 solutions to this question. We have 2 real solutions and 4 complex solutions. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.